We live in a violent universe. Planetary winds rage at 6 times the speed of sound. Lightning storms stretch for thousands of miles. Dust storms engulf entire worlds.
We can have planetary storms, the like of which we never see here on the planet Earth.
The largest storms can be on the scale of entire galaxies.
Sometimes those massive stars can literally explode.
The universe is a chaotic place. Earth has storms. Other worlds have megastorms, storms almost too vast to imagine. Yet from the violence emerges a ray of hope.
We kind of owe our existence to these sorts of events, these sort of galactic storms.
Could megastorms be necessary for life itself? On some planets, storms are impossible. Superheated Mercury is too small and too close to our sun to have a significant atmosphere. And no atmosphere means no storms. But move out away from the sun, and we find worlds with turbulent, chaotic atmospheres. They can spawn some of the most awe-inspiring megastorms in our solar system. This is Venus, a planet completely shrouded with clouds. Winds rip around the upper atmosphere at over 300 miles per hour.
About 35 miles above the surface, the winds are whipping around in a ferocious pattern that basically carries the cloud features around the entire planet every 4 days.
Venus is closer to the sun than Earth, and it's heat from the sun that drives the wind.
The circulation pattern of Venus's clouds is actually quite simple. There's a warm side of Venus and a cold side. And as air warms up and rises on the day side of Venus, it spreads around to the night side. So there's this continuous current. It's actually quite a lot simpler than the atmospheric circulation on Earth.
Venus's winds circulate faster than the fastest hurricane on Earth. But they look very similar. The Venus Express probe captured these remarkable images of the planet's south pole.
One of the great mysteries of Venus, which actually had jaws dropping in the halls of many astronomy departments, is the fact that we have hurricanes at the poles of Venus, especially in the southern hemisphere, that have 2 eyes. Not 1 eye, but 2 eyes. Now, we've never seen this before on such a planetary scale.
Venus's double-eyed vortex is 1,800 miles wide. 2 hurricanes whirl around each other.
If you could descend into the vortex of Venus, something I would love to do, at least with a remote machine, I think you would see some kind of a fantastic wall of cloud and this sort of twisting form spinning around you at ferocious speeds. It would be quite a sight.
It's a mystery how deep this raging, spinning vortex goes. But maybe this megastorm eye descends to the planet's surface. Down here, permanent twilight bathes a volcanic landscape, and the atmosphere's colossal weight creates immense pressure.
And the atmospheric pressure on Venus is about 100 times that of the Earth. Think of taking a car, squeezing it down to about a square inch and putting it on every square inch of your skin. You would be flattened within a fraction of a second because of all that pressure.
Venus's dense atmosphere creates one of the strangest megastorms imaginable. 4 miles per hour winds with the force of a hurricane.
The winds on the surface of Venus are actually very slow because Venus has a very slow rotation rate. It takes Venus about 8 months to turn once around with respect to the Sun.
The crushing atmospheric pressure rams gas molecules together so tightly that they feel more like a liquid. A gentle 4-mile-an-hour breeze packs a brutal punch. It's like a hurricane in slow motion.
Winds on Venus are totally unlike anything we see on the planet Earth. You would almost feel like a molasses effect. It'd be quite difficult to simply walk and run right through the wind.
Venus's surface is so hostile that life is impossible here. But the upper atmosphere's faster winds hold an extraordinary possibility.
Well, I harbor this, I don't know if I would call it a hypothesis or a scientific fantasy, but I do think it's plausible that there could be some kind of life living in the clouds of Venus. There are certainly energy sources, there's sunlight, and there are certainly nutrients. There's carbon, there's hydrogen, there's oxygen. All the stuff we think of that you need to make life exists in the clouds of Venus.
Earth's upper atmosphere is full of life. Microscopic bacteria drifting on the wind. Could Venus be the same? Perhaps one day we'll send a probe to find out. Leave Venus behind, and the next planet is Earth. Here, too, the weather gets extreme. We are bombarded by tornadoes, hurricanes, and these dust storms. On Earth, they're localized. But on the next planet out, they engulf an entire world. Over 100 years ago, astronomers thought they had found life on Mars. A dark wave spread from the pole towards the equator. They thought it was springtime vegetation spreading across the planet. They were right about the season.
Mars tilts at roughly 23 degrees like the Earth, so you would have summer, fall, winter, spring like the seasons.
Seasons bring weather. The shadow astronomers saw was actually dark rock uncovered by a violent dust storm. It's all because of the way the planet tilts. The Earth takes 1 year to orbit the Sun. In January, the northern hemisphere leans away from the Sun, and we get our winter. In June, it leans inwards, our summer.
Mars has gigantic planetary dust storms, the like of which we've never seen here on the planet Earth.
Mars has around the same tilt as Earth, and springtime means storms. The Martian surface vanishes under a cloud of raging dust particles. On Earth, we get dust storms too. They can be devastating, swallowing entire cities. July 5th, 2011, Arizona. An unstoppable 5,000-foot-high wall of dust smashes into Phoenix. Day turns to night. Thousands of tons of dust settle over the city. But the disaster stays in one place. Mars's dust storms can engulf the entire planet.
On Mars, when dust gets kicked up once, it lands, it can get kicked up again and again. The dust is reusable. On the Earth, when dust gets kicked up and then finally settles out, it's probably going to settle out into the ocean, where it's gone for good.
There's nowhere on Mars where there isn't ready dust and sand to add to that storm. So these storm systems can kick up and last weeks or even months.
Mars's incredibly dry atmosphere contributes to the storm's size and power.
In the case of the Earth, dust that gets up into the atmosphere is rapidly washed out by the rain and gets into the ocean. In the case of Mars, there's no comparable rain to wash the dust out. So once the dust gets into the atmosphere, it just sits there until the particles by themselves are able to slowly settle out.
A lack of rain allows Mars's dust storms to cover the planet. But dust storms on Mars can be equally spectacular on a much smaller scale. NASA rovers captured these extraordinary images. Dust devils sucking up fine, dry iron oxide dust. The biggest dust devils can reach 6 miles into the sky. They pump fine particles high into Mars's atmosphere, creating a haze of dust that may help control the planet's dry climate and lead to a planet-wide megastorm. Even on Mars, dust storms this big are rare. Astronomers have detected just 10 in the last 100 years. What the ancient astronomers mistook for life was a megastorm. But even a planet-covering dust storm is dwarfed by the weather on the next planet out from our sun. This is the giant of our solar system, Jupiter. Jupiter is gigantic. It's 2.5 times more massive than all the other planets in the solar system added together. It's also home to gigantic megastorms. Jupiter's high-speed rotation drives vast bands of counter-rotating clouds. Colossal storms build along the boundaries. And this is the biggest of them all. The oldest storm in the solar system. 15,000 miles across and over 300 years old. The Great Red Spot. Around the edges, turbulent winds rage at over 300 miles per hour.
The Great Red Spot is a giant vortex, meaning that in the case of the red spot, it has a high pressure center with winds that swirl around the outer edge. So in that sense, the Great Red Spot is a little bit like a hurricane.
A hurricane with a difference. On Earth, hurricanes feed off heat from the ocean. When they hit land, they start to die. so on average they last only about a week.
Jupiter does not have land. Jupiter is a completely gaseous planet, and the friction there is very weak. And so a vortex, like the Great Red Spot, can last indefinitely. There's nothing to slow it down.
To keep going, all the red spot needs is a power source. On Earth, ultimately that's heat from the sun. But Jupiter's 5 times farther from the sun than us. Heat from the sun is not enough to drive the red spot. Instead, Jupiter has an internal power source, its own immense gravity. In 1995, NASA launched a probe straight toward the giant planet's heart. It plunged into Jupiter's upper atmosphere at over 106,000 miles per hour. As it fell, the planet's crushing gravity ratcheted up the pressure 10, 15, 20 times what we feel on Earth. Winds gusted to over 400 miles per hour. The probe gave out just 100 miles in, crushed by pressure and fried by the incredible heat the pressure generated. Had the probe made it deeper, it would have reached a vast silvery ocean. Intense pressures here turn hydrogen gas into a churning metallic liquid, superheated to over 40,000 degrees Fahrenheit. Jupiter's interior pumps out about twice as much energy as the surface gets from the sun. This is Jupiter's power source, the heat that drives its massive megastorms.
All of the convection, all of the heat comes from the hot, dense interior of the planet itself. So the bands of clouds that you see that are even counter-rotating, going in different directions, those are all driven by the internal heat of Jupiter itself.
Jupiter's internal heat drives its violent megastorms. But the giant planet may hold clues to an even deeper mystery. Could life exist on other worlds? NASA's Cassini probe studied Jupiter as it flew past en route to Saturn. It made an extraordinary discovery. Strange white clouds just north of the Great Red Spot. Clouds just like the clouds on Earth. Droplets of liquid water. Could Jupiter have the ingredients for life?
The question of life on the giant planets is an interesting one. You have many of the ingredients for life. You have sunlight coming in, there's liquid water, at least in the form of cloud droplets. On the other hand, if life can easily exist in clouds, you might expect that bacteria and algae would populate the clouds on Earth and the clouds would be green. We don't see that on the Earth. We do see microbes at many altitudes throughout the Earth's atmosphere, but they seem to largely be blown off of the surface.
It's likely that life on Earth began on a solid surface. But could life evolve without one?
There's no surface on Jupiter, and so that makes it difficult for organisms to have a constant source of water. So if you imagine yourself being a little bacterium inside a cloud droplet, you're going to be in deep trouble when that cloud droplet evaporates.
Whether life exists in Jupiter's clouds or not, gas giants like Jupiter and its neighbor Saturn have all the right ingredients. water, heat, and one other vital element, a spark. Lightning on an unimaginable scale. These haunting images are from NASA's Cassini probe. Its mission, to explore one of the solar system's most awe-inspiring planets, Saturn. The probe reveals Saturn's rings, moons, and the planet itself in near-perfect detail. Chaotic bands of cloud race around Saturn at more than 1,000 miles per hour. Finding storms here was no surprise. It's a planet of storms. But this was astonishing. A bolt of lightning. A gigantic thunderstorm on an alien world. Lightning creates some of the most spectacular weather on Earth. Electrical tension builds between the top and bottom of a vast 55,000 feet high storm cloud. A maelstrom of water vapor, rain, and ice. Tiny ice crystals drive up past hailstones falling down. As they rub past each other, it builds up a charge. When the strain gets too great, you get an electric spark. On Earth, the average lightning storm stretches 15 miles. On Saturn, they can reach around the whole planet.
There are examples of lightning storms on Jupiter and Saturn where the anvil cloud, in other words, the big cloud at the top of the storm, starts small and grows to be 20,000 kilometers long. That's the size of the Earth.
On Saturn, we registered one lightning storm that was 10,000 times greater than any lightning storm found on the planet Earth.
Lightning is hotter than the surface of the sun. The atmosphere literally explodes. The sound we call thunder. On Earth, it's the sound of new life.
Lightning seems scary and destructive, but actually it's very productive for life on Earth. And the reason why is because of its influence on atmospheric chemistry.
Every bolt literally burns the air.
When you have a lightning discharge, you get this very high temperature, very energetic plasma, and that breaks up the nitrogen molecules in the atmosphere, frees up those nitrogen atoms to enter into other kinds of molecules. And those nitrates formed by lightning allow nitrogen to go into the soil as basically fertilizer, enter into plants, enter into the life cycle. So it's the lightning that frees up nitrogen atoms in the service of life on Earth.
Earth experiences 8 million lightning bolts every day, helping life evolve and colonize the planet. But for Saturn, lightning alone may not be enough. There's nowhere for alien life to live. One place in our solar system may solve that problem. Saturn's moon, Titan. It has an atmosphere. It has lakes of liquid methane. And its own bizarre brand of megastorm. Saturn is almost 900 million miles from the Sun. This far out, orbiting the Sun takes time. Saturn's year is nearly 30 Earth years long. Right now it's spring, and things are heating up.
Moving into the summer cycle of Saturn. So the atmosphere is slightly heating up, even as distant as Saturn is from the Sun. We've got a little more energy, and we're seeing the most spectacular storms we've ever observed on Saturn.
After years of frozen silence, Saturn is coming alive. Scientists have waited nearly 15 years for the Sun to light up its North Pole, to reveal extraordinary details about one of the strangest megastorms in the solar system. Saturn's unique hexagon storm.
A hexagonal pattern, how can that be? In Mother Nature, we have jagged objects. We don't have geometric figures arranged precisely, especially at a gigantic planetary scale. However, there's some theories. If I take a bucket of water or a bathtub and simply vibrate it, I get waves that travel. But there's another kind of wave. You have traveling waves, but then you have stationary waves. Inside a bucket of water, you can get resonances. Water pulsates like this. And you can also get them to pulsate in a circle like this to create regular patterns. These are called stationary waves, and we think that this mysterious hexagonal pattern on Saturn is a hexagonal standing wave.
The megastorm at Saturn's North Pole is a wind that travels at hurricane speed, cornering sharply 6 times as it races round the planet. The central clearing is so big, you could fit 4 Earths inside. What lies beneath its surface is a mystery. As Saturn warms from spring to summer, another world comes alive too. One of Saturn's moons, Titan, is warming up. And with the warmth come the storms.
One of the most interesting moons in our solar system is Titan. It's straight out of science fiction. It's an object with yellow skies and methane clouds that is truly remarkable.
NASA's Cassini probe reveals Titan in unprecedented detail. A thick, dense atmosphere, vast mountain ranges, lakes of liquid methane. And this, an arrow-shaped band of white methane clouds moving over its surface. When the clouds drifted over a dusty open plain, seen here as a dark patch, the dark patch of ground beneath the clouds grew larger. Scientists believe liquid methane drenched the surface. A spring rain storm, Titan style.
Rain on Titan, if it exists, would be very different from rain on the planet Earth. First of all, the gravitational field is very weak, so you would actually see raindrops falling very slowly at you. Also, the size of these droplets could be much larger. But don't get caught in a rainstorm on Titan. Those droplets are awfully cold.
Titan's methane monsoon sweeps across the moon. Weak gravity creates ultra-cold, hazelnut-sized raindrops. an alien world with truly alien weather. These slow drops have carved valleys and lakes, much like ours on Earth. A slow-motion megastorm. But fly even farther out through the solar system, and you find storms that are altogether faster. This is super-chilled Neptune. The temperature never gets above 300 degrees below zero.
Neptune is one of these giant planets. It's much larger than the Earth and has a very thick atmosphere. It's about 2 billion miles out from the Sun. So you really might expect, since it's that far from the Sun, it would be very cold and not have very much weather. But in fact, Neptune is very dynamic. It's got tremendous weather patterns.
Despite its incredible distance from Earth, astronomers can get close to Neptune's turbulent atmosphere. With a little help from this. The Keck Observatory. 14,000 feet up on the summit of Mauna Kea in Hawaii. It sits above Earth's clouds and pollution. The telescopes are so powerful, they could see a candle on the moon. Neptune at first appears featureless, but a closer look reveals white, high-altitude clouds in the upper atmosphere. It's a perfect opportunity to track wind speed. Measuring the time and distance the clouds take between 2 points allows scientists to clock their speed. The Keck telescope swings towards Neptune. A series of shots track the white clouds as they move around the planet.
So here we can take several photographs that show the positions of clouds apparently changing. You can measure the position at one moment to be there, and at another time, a few hours later, to be in a different place. Now, most of that change in position is due to the rotation of the planet as a whole. However, if you know the rotation rate and subtract that out, that gives you the motion of the clouds relative to the planet. That tells you the wind speed.
The results are shocking.
We're seeing wind speeds on Neptune of many hundreds of miles per hour, up to 12 or even 1,260 miles per hour for the very fastest clouds. That's really phenomenal.
Neptune has the fastest winds in the solar system.
So what's driving this? You need energy to make weather. Where's that energy coming from? And it turns out it's coming from Neptune itself. It does receive sunlight, but Neptune actually radiates away more energy, a lot more energy than it gets from the sun, which means the interior is very hot. Probably it means there's radioactive material in there, there's leftover heat from when Neptune formed 4.5 billion years ago that's very slowly leaking out. And it's that that's heating up the air and driving all of the circulation and all of this crazy weather that Neptune has.
Neptune's storms hit hard. But the search for truly extreme weather takes us out of the solar system altogether, into uncharted territory. Out here, there are storms that make even Neptune's winds look like a breeze.
Katrina was just a sneeze compared to the winds we have on Osiris.
The search for megastorms leads to alien worlds whose violence defies imagination. Space is full of stars and planets where violence and chaos reign. Astronomers scour the skies for new worlds, and the king of the planet hunters is Professor Jeff Marcy. He scans the night sky seeking new worlds around distant stars. Marcy's team has instruments so sensitive they can even predict the weather on these distant planets. This is Osiris, 150 light years from Earth. A planet from hell with matching weather. Earth is 93 million miles from the sun. It orbits the sun in 1 year. But Osiris is just 4 million miles from its star. Its year races by in just 3.5 days. When Osiris passes between us and its star, starlight briefly shines through its atmosphere, giving us a glimpse of conditions on the alien world.
And they waited until the planet was in front of the star. At that moment, some of the starlight passed through the atmosphere of the planet. They were able to do essentially a chemical assay, a chemical assessment of the composition of this atmosphere.
Osiris gets blasted by the intense heat of its star. Temperatures top 2,000 degrees.
Now, what that means is that the environment on that planet is, well, hideous for life as we know it. But even more, the intense heat causes the gases to expand, and they have no place to go but the backside of the planet.
Osiris is tidally locked. The same side of the planet always faces the star. The other looks out into space. The temperature difference is immense. Superheated atmosphere roars from the bright side of the planet to the dark at nearly 6 times the speed of sound.
In fact, the winds will be something like 2,000 or 3,000 miles per hour. Enormous speeds of these winds, 10 times, 20 times faster wind speeds than the strongest hurricanes. Katrina was just a sneeze compared to the winds we have on Osiris.
Osiris is a brutal world. Too hot and too violent for any kind of life we could imagine. But there are even larger megastorms, storms on the scale of whole galaxies. And these vast storms may be the reason any of us are here. The Hubble Space Telescope captured this stunning image of the galaxy NGC 3079. At its center, a superwind, a storm on a truly cosmic scale. It was triggered by an explosion from a forming star. This raging galactic storm is about 3,000 light years wide. It has already raged for around 1 million years. Filaments of 20 million degree gas tower above the spiral galaxy. This cosmic megastorm wreaks havoc within its host galaxy.
We see bubbles and jets and formations of gas falling into the galaxy, colliding with galactic dust.
The gas from the galactic megastorm smashes into gas and dust at the heart of the galaxy and compresses it into a swirling mass of matter. Gravity takes over. The compressed clouds of gas and dust get tighter and tighter. The center gets hotter and hotter. Finally, it ignites. Powerful winds from the new star blast into space. The whole cycle begins over again, and a new galactic megastorm is born. Around the fledgling stars, dust and rock come together. The birth of new worlds with rocky surfaces where life could begin.
And perhaps the formation of life itself may be determined by how these gases swirl and create supergalactic storms. And if you have galactic winds churning away, then that would help to distribute the elements necessary for life throughout the galaxy. So galactic storms may in some sense be one clue to the formation of life itself.
Galactic megastorms rage for millions of years. Billions of years ago, they may have created new homes for life in our Milky Way galaxy. On every scale, storms are not just a force of destruction. They are linked to creation itself. The search for life on other worlds is also the search for storms.
When you disrupt the status quo, you open all kinds of possibilities for things to reassemble in different ways. So chaos or disruption is actually an important factor in the development of complex systems like life.
A planet that might have changes of seasons, volcanism, intense storms, some environmental factors that you might think could be damaging to life, in the long run makes life stronger.
Earth has storms. Other worlds have megastorms. Whether it's lightning on Saturn, the turbulent atmosphere of Jupiter, or blistering temperatures on Osiris, vast, violent, and deadly, megastorms could also be the catalyst for life.